Good morning, friends. Have a good day. My dear friends, life is not full of fun. Life is not full of thought. It is full of up and down. So don't stop with a frown. Honesty is the main quality. Learning is the next priority. Be bold and keep faith in God. Move ahead and work hard. So, in previous learning, we have observed that penalty from state electricity board will be imposed if you cross the contract maximum demand and for low power factor. Contract demand is expressed in MVA, mega volt ampere. So the multiplication of voltage and current will increase the MVA if any one of these is increasing. But the voltage variation is permitted only 5% in traction system. So it is not the factor. The factor is load current. If the number of trains are more, the current will be more and the MVA will rise. So it can be controlled by controlling of train. That is actually practically impossible. Implementation of neutral section in every traction substation so that feed extension can be shared, or if any section having little trains and another one is full of trains, then the load of the little trains of one traction section can be extended over the zone of loaded traction substation, but it is not fully, because we have provided PTF in neutral section in front of TSS. So 50% load or 50% distance of the TSS can be shared, means PTFE to PTFE. From one TSS PTFE to SP PTFE to next TSS PTFE, we can share it by monitoring the load current. Where the load current is somewhat little or less, then we can extend that feed over other zone where it is loaded. But how? That will show you. And another is power factor. Power factor is due to inductive load. Our traction transformer itself is inductive load. Earlier locomotives all are inductive load, though nowadays the modern locos is running with unity power factor, these AC locos. So due to inductive load, our power factor is low. To compensate it, we provide capacitor bank. Capacitor bank is also two types. One is switching capacitors and another is shunt capacitor bank. Switch capacitors, when the load is more, number of capacitor unit will be inserted in the circuit, and when the load is less, it will be disconnected automatically. This system is automatically. But for shunt capacitor bank, the capacitor is fixed, and if there is low load or no load, then the power factor may become leading. At that time also it will reduce. I will show you all these things how. Let's see. Suppose B traction substation is overloaded and MD may overshoot. So due to PTFE in front of the TSS, we can share its load to the adjacent TSS. See how. How we utilize power sharing by providing PTFE in front of traction substation. Here, suppose BTSS is overloaded, so we can share its load to the adjacent TSS. Just like here, we shared the BTSS load to A TSS by closing bridging interrupter at SP and feed it shared. Again, if power supply at BTSS is fully filled, we can share the load by C and A both partly, so that total load of B partly shared by C and partly shared by A. This is all the facilities of PTFE, providing PTFE in front of traction substation. So the total load of B traction substation due to power failure is shared partly by C traction substation and partly by A traction substation. So it is increasing the reliability of power supply, as because railway is a 24 hours power requirement service due to train movement for 24 hours. It is emergency service, so we cannot interrupt the train movement, the traffic movement. So immediate power will be arranged by from the adjacent power supply source.